we're now going to look at rates of change. The rate of change of a variable is the same as the gradient, since gradient by definition is how much y changes for every change in x. Therefore, a rate of change question is, in essence, just a gradient question. With calculus, we still have the concept that it's instantaneous because the gradient is changing all the time for a curve, but nothing else is changing. So, when you're faced with a rate question, it's just a disguised gradient question. And one of the disguises is that the letters used are different. But just because something replaces x and y doesn't change the underlying maths. We'll do one. We're asked to find the rate of change of volume V at 5 seconds if we're given that function. So this tells us the relationship between volume and time. Vt is our function, and so we just treat it the same way that we would have treated function of x. And we can differentiate it with respect to t. 24, t becomes 24, 2 comes down, so it's minus 2.4t. So that new gradient equation, v dash, is our rate of change of v with respect to time. And we're asked what is the rate of change at 5 seconds. So we stick 5 for t into our rate of change equation, and the answer we get is 12. So our rate of change at 5 seconds is 12. Now look again at that question, you'll see that it is really what is the gradient, the rate of change of quantity v, but that's y, at t equals 5, which is x is equal to 5. What is the gradient of this function at x is equal to 5? Nothing else has changed except the names and the letters. We'll do another one. The level in a bucket is found by a relationship, and when is that level dropping at 4 millimeters per hour? The level is given by that, so the rate of change of the level is given by its differential. L dash, or dl dt in this case, is our rate of change of L, and it's minus 4 when the level is dropping at 4 millimeters per hour. So we solve the equation. Minus 4 is our rate of change, and our rate of change is 2 minus t, and that yields t is equal to 6. So the level is dropping at 4 millimeters per hour after 6 hours. If you look at the questions again, you'll see that this can be thought of as the level, the value of y is found by this relationship, and when is the gradient equal to minus 4. That's the process we followed, just with different names. So rate of change questions are solved exactly as if they were gradient questions, except the quantity replaces y and time replaces x. The equations for rate are the gradient functions, and we find them by differentiating in the same way that we find a gradient function. q dt, or q dash t, whichever form you're going to use, gives the rate of change of q with respect to t. And the actual process of differentiation is exactly the same. The power of t is multiplied by the coefficient in front, and then the power of t is reduced by 1. Otherwise, the process is the same.